just recently, a client in Batangas also received our delivery for this stainless steel poles. No? So today, we are now suggesting the use of stainless steel poles. Well, the client is very close to the sea, so we have to recommend to them the use of stainless steel pipes instead of the usual galvanized iron pipes or GI pipes. There is a base of that stainless steel pole, about 8 meters high, and here is the tip, the highest point where you have to insert your lightning arrestor device. And this is a picture of the one that we use for making the ground connections. No? And here is an example of how it is done. Here is a ground rod, and these are the ground wires or ground cables, and this is the ground connectors. Okay. So now we go to lightning protection of electric power lines and equipment. Okay. In order to protect your expensive equipment like this transformer, lightning arresters should be mounted as close as possible to the terminals. No? Take note of this comment. Lightning arresters should be mounted as close as possible to the transformer terminals, preferably within 3 to 4 feet from the terminals. Why? Because it is the winding of the transformers that must be protected. It is the most delicate part of the system because of the winding, especially in the high voltage side. We have the wires there, and it is only filled with oil, or sometimes they are insulated with what's this? Plast, epoxy kind of insulation. But most of our substations are insulated with mineral oil. So therefore, the windings are the most delicate parts. It is the one that would be damaged when the traveling waves from lightning would reach the terminals of the transformers. No? Okay, here, this is another one of my comments. For optimum voltage surge protection, station class or intermediate class 20K or 10K lightning arresters, or even higher, should be used for such substation. Arresters should be used distribution class for distribution type transformers. So as transformers are bigger in capacity, you have to provide higher capacity station class in the range of higher than maybe even 20 kA. And here is an example of lightning arrestor mounted very close to the terminal of distribution transformer. Here is one, and here is another one. Okay. And here are also lightning arresters that are of, take note, they are of higher capacity than these two, which are only for distribution type arrestor. This one is more of a power transformer that's mounted on a pole, but you will take note that the arresters are of higher capacity. The diameter of these arresters are bigger than those in this transformer. So that's how we protect our lines, transformers, and so on. So in other words, because you cannot cover all the earth with lightning rods, okay? The power lines, the power company, distribution company, electric cooperatives, and the transmission company will have to provide arresters, lightning arresters in their power lines. How about inside buildings? Lightning surge protection inside buildings. Okay, let me see who are here. Oh, John Dobus again is in the house. Good evening, Sir Will. Good evening. One Asia Electrical, Bunny is still is also with us again. Good evening to all. Good evening, Sir Will from Bani Agata. And Rexter Valdez. Hi, sir. Good evening. Banded po ba lahat ang air terminal with the conductor? And what is the maximum number of air terminal for one rod? Okay, it is the minimum number of grounding rod for a building should be two. No, it should be two. In other words, if you have air terminals on top of your building, there should be at least two down conductors and at least two ground rods. That would be the minimum. At least if one would be cut, then there's still the other one. Okay, so that is the minimum. And of course, because it is a passive type, you have to put as many air terminals as possible. A comment from Bani. Number one, what is the minimum distance of the two ground rods, sir? These ground rods shall be or should be bonded to other ground rods within the building. Yes, of course. In the passive type lightning protection system, I mentioned, say it's an elongated building. If you have so many terminals at the top of the building, on both ends, maybe left and right ends, well, you would have at least one ground rod, minimum of one ground rod on each end. Okay, one ground rod on each end, and therefore, meaning to say, as you could imagine, an elongated building, or maybe let me just go back to this slide. Maybe yes. Wait, I'm just trying to scan a figure earlier. Let me just go. I'm trying to go back. So here. So say for example, if you would have this, no? Say this if you only have this very long building here, if you have so many air terminals here, 1, 2, 3, and 4, then you have one ground rod here with one down conductor. Then maybe you will have another one in here, one down conductor here, and another. That would be the minimum that would be provided, because there is this part of the building here. Then that included another one. Okay, so let us just review. There's one in here, another one in here, another one in there. But if it is only a simple building like this main building here, you can see it, no? Then there will be minimum of two, one in here and one in here. Okay, so that's how it should be done using this passive type. But of course, the number of air terminals would be as many as you can. Okay, maybe like in this, it doesn't really mention. Oh, it mentions here about 20 feet apart. 20 feet apart. So that's about 6 meters apart. 6 meters, 6 meters, 6 meters. So there will be so many of that. Okay, and of course, this is a high portion. You have to provide again that, no? But there's a problem here. You have an antenna. And therefore it is a candidate for possible strike by the lightning. Okay, I hope I was able to answer Bani's question. Let us go back to that slide where we stopped. Here. Let me go back to the chat room. Okay, John Docos. I'm just looking at the question of Bani. What is the minimum distance? You mentioned the two ground rods are very far, so no problem. Must be an edge minimum, no? If you have that would be the minimum, and then these two ground rods shall or should be bonded to other ground rods. Yes, it should be as much as possible. No? Not the ground rods that are used for the electric grounding of the electrical system, okay? Because the ground rods which you use for lightning protection should be independent of the other grounding system. You see, you have a grounding system for your electrical distribution, and you have a grounding system for your communication. So you must also have a separate grounding for your lightning protection. Okay? So, John Ducos, sir, will need pa po ba ang wire shielding sa air rods? No need. They would usually be a bare copper wire. The only time that I would suggest an insulated cable is when the grounding conductor is being used in a residential building. Say, for example, you have a condominium
Backgrounder.
of,
Grounding and
say,
shielding
22
electrical
stories
distribution
high,
systems are of key
and your
importance to
ground
electrical
down conductor
practitioners.
will be passed through
Understanding the basic
maybe
operations
along the
between
elevator
grounded and
shaft,
ungrounded electrical
and it
systems is necessary for matching
could
the
be
appropriate grounding arrangement to the
within the
desired
concrete of the
electrical
elevator
system
shaft.
performance.
Although
The
the
purpose of
conductor
grounding an
could be
electrical
passed through
distribution
a
system is
PVC
to limit the
insulate,
voltage
but
imposed by
because it is
lightning,
passing through
switching
inside the cross section
surges, line surges, or
of the
any
concrete
unintentional contact with which higher
shear wall
voltage
of
lines
the
that will
elevator shaft,
stabilize the
my
voltage to Earth
suggestion
during normal
is
operations.
we should be using insulated conductor,
Disadvantage of
no?
ungrounded
Maybe like
system.
a 600 volts
The
insulated
disadvantage
conductor,
of an
not the
ungrounded
bare
system is
conductor.
that a first
And
phase
that
to
is
ground
only
fault
true
condition can
inside
be difficult to find.
buildings
The
that
voltage to ground in an
that have
ungrounded
people
system
living
is
in it.
0
Because
volt,
we do
in
not
theory,
know when
because
people
there is
would
no
be
ground
touching the
connection
wall
from any
of
system
the elevator
conductor.
shaft, and
However,
lightning
there
would
is a
strike
distributed leakage
the roof of the
capacitance
building.
present through
So
such
we do not
systems.
know. There might
Phase to
be
ground voltage
uh,
levels can appear
a
during
high
voltage
voltage
testing
gradient that
and are
may happen.
usually the result
But
of
if it is
capacitance coupling
a
effects from
lightning
the
protection
system
in
circuits.
industrial plant,
But when is an
in
ungrounded
solar
or floating system
areas,
mandatory?
in open areas
If a
where
ground fault
chances are
occurs in
people
an
are not there,
ungrounded
no?
system, shutdown is
Meaning
not
to say, like in
necessary.
an industrial plant,
This is also the
you know,
reason why floating
the
systems are
manufacturing people
mandatory
are
in life
usually
support systems in
inside
hospitals,
the control
e.g., in
room or
intensive
maybe their
care
offices
units,
and so on and so forth.
operating
So
rooms, delivery
I'm
rooms,
talking
and
more of
emergency
where
room.
people
In the event
are
of a ground
habitated,
fault,
no?
the
They
supply to
sleep,
life
they
support
stay.
equipment is
So we
maintained.
have to put
The
some
ungrounded
extra
system is in
protection
general perfectly
and
suitable for all
possible
applications in which
voltage that
shutdowns
might
are
be
unwanted,
caused
would have
by the
serious
voltage gradient. Remember,
consequences.
in
In the
one slide
process industry,
earlier, it
in
mentions
data
a
centers,
million
in
volts. Of
automation,
course, nobody has ever
etc.
measured how high the voltage of lightning. Some say a million volts, but there is already researchers that I saw in one slide talking about a range of a million volts, a hundred million volts. So that means, therefore, that the voltage gradient could be very, very high when it strikes the top of your building.
Indoor lightning safety. The best protection from lightning is a house or any other substantial building. Second best is a hard-topped, all-metal car. Lightning can travel through electrical outlets, phones, plumbing, and television reception systems. Stay off from corded phones. Don't touch electrical equipment or cords. Avoid plumbing. Don't wash your hands. Don't take a shower or wash dishes. Stay away from windows and off of porch. Phone use is the leading cause of indoor lightning injuries.
Here, I just got a graphic showing how a varistor lightning arrestor would perform with the different voltages that might that might strike a lightning arrestor. So this is an area here on the left where you would see the varistor voltage still very low. Okay, and then of course this would be the breakdown region portion. Okay, and this would be the switching charge region, and this would be the range where there would be the lightning charge. So in other words, the varistor, the characteristic of this material is it varies its resistance with respect to the, the magnitude of the voltage. As the voltage is higher, like in this region, high current region, it would allow, the varistor would allow the flow of big current. In other words, the varistor will produce a very, very low resistance to allow the flow of high current. So high voltage, very high voltage, lightning voltage, the current will be very high, okay, and therefore protects by allowing the big current to flow to the ground. And during switching, it is a little lower, okay, and the TOV region, the breakdown region, and the normal operating regions here. So in this portion, you will notice that the current during normal operation is very, very small. While you see in here, you can see up to a maximum of 100,000 amperes. 100,000 amperes, and 10,000 amperes here, and 1,000 amperes here, and 100 amperes. So that's how the varistor lightning arrestor type of material, the characteristics of this kind of material. Okay, now we go to lightning arrestor protection for, let's say, inside the house or buildings. So here we have a simple incoming circuit breaker, and a feeder, and you would see here sensitive loads. So sensitive loads are those electronic loads like computers, or some TVs and printers, servers, and so on and so forth. Usually these appliances or devices or equipment converts the AC to DC, and of course, therefore, they are prone, because they are only working at a very low voltage, they are prone to damage by lightning charges. The non-sensitive loads like lighting, like the electric fan, or other motors that are not provided with electronic sensing or protective equipment are usually has the capacity to absorb this lightning charge. So therefore, these sensitive loads would be the one that we be protected, and therefore, your surge protective device should be very close to this. It must be provided. Or sometimes, in our case, we would be providing the outlet where we connect the sensitive devices with surge protective devices. So sometimes you would see these products being sold from the hardwares, from other companies, where you have a portable outlet, multiple outlets with an extension outlet, which is already provided with a surge protective device. Okay, and here's another schematics that would show you transformer outside of a building, but of course the incoming is underground. But you may never know from the incoming side here if, since in most cases would be delivered from far away long transmission lines, so there's always the possibility that lightning strikes those far away transmission line, but sometimes the lightning arresters installed in there would not be able to contain the traveling waves caused by lightning. Not all. Of course, some would be able to trap it and ground it, but still some would reach this transformer. And when it reaches this transformer, it can also get inside the building or the house. So therefore, it is important to install your surge protective device here. This one here, okay, there's one in there outside, but here is provided within the panel board, or very close to the panel board. So the moment the lightning surge would reach the panel board, it should be protected by this pink colored surge protective device. Okay, and of course this is an extension outlet where your desktops, laptops, and other electronic devices are also connected. So this was the outlet that I was mentioning to you with a surge protective device. So that's sometimes the way we protect this very sensitive equipment. So if you do not have this surge protective device, chances are when there is a lightning surge coming from outside, you might be damaging your sensitive electronic devices. Okay. And here are pictures of this typical low voltage surge protective equipment. They look like circuit breakers, but they are surge protective device. or SPD. And you would see the specs in here, 275 volts maximum operating voltage, and minimum current, allowed current is 20 kiloamperes, and the maximum is 40 kiloamperes, and the maximum voltage range would be 2 kV. Okay, so that's how this would be. But let me show you how you could specify this kind of equipment. So here is a slide that would show you the standard ratings of this low voltage SPDs. Here is a maximum continuous operating voltage. So it could be 275 volts or 440 volts, or it could be a 275, 320, 385, or 380, or 400, and a 440 volts, or it could be 375, 385, or 440 volts. Okay, so if it is 440, that means it's American standard, and below 275 is, let's say we have the 220 volts in our country, so you can also use this maximum operating range. Then here is voltage protection level, so 800 volts or less, then 1000 volts or less, 1 kV or less, and here is 1 kV for 275 volts, and 1.4 kV for 320 volts, and 1.6 kV for 385. Same with here, 1.8 kV for 440 volts, and here is 2.2 kV for 385, and here on a 440 volt system is 2.4 kV maximum protection. And here's the nominal discharge current, standard discharge current, within 20 microseconds is, here is 5 kiloamperes, here is 10 kiloamperes, 15, 20, 30, and the maximum is, nominal discharge is 40. And the maximum discharge current is 10, 20, 30, 40, 60, and 80. The response time is about 25 microseconds, so very, very fast. And test standards is British and IEC standards. And here are cross-section of line. Here is the rating. Fuse or breaker or switch. This one is very small, 10. And here is 16 and 32, and here is 40. So these are for small branch circuits, protection for small branch circuits. So let me just show you how you would select it. I included here example 1. What is the recommended surge protective device for a 320 watts inverter type refrigerator connected to a 20 ampere 230 volts single phase branch circuit? So we are talking of an inverter refrigerator. So remember, in an inverter, you are changing the AC to DC and inverting it again from DC to varying frequency AC. So remember, the inverter equipment is quite expensive. So we have to provide for protection, surge protection, so that we can assure that the life of this sensitive appliance, inverter type appliance, is long enough, no? So, okay, the way is, since we are already given the branch circuit here, which is 20 ampere, my suggestion is to use either a 20 ampere or 30 ampere SPD, or an SPD that would be in this range. And the maximum voltage or the minimum voltage range of the SPD should be 380 volts, and the minimum nominal discharge current should be 15 kA, and the maximum discharge current of 30 kA. So let's go back to the previous slide. So here we have a 15 kA and 30 kA. nominal and maximum. Let's go back. So 15 and 30. So this must be 15 nominal and 30. And here is the voltage range. Is it okay to use 5 and 10? Well, because this one is only up to 275. It means if you are a 220 volt circuit, this one could be enough. But of course, since we are talking of an expensive equipment or appliance, I would suggest selecting this higher protective range, 15 kA and 30 kA. So you have to select this kind of equipment. Okay, let's go back to this slide. Example 2. What is the recommended SPD for a voltage sensitive equipment powered by a 10 horsepower motor connected to a 30 ampere 460 volts 3-phase branch circuit? So again, we're talking of the sensitive equipment. Okay, sensitive equipment, again, there are electronic circuits provided in the control circuit of such equipment. If it is only a simple Y delta starter, simple reduced voltage starter, reactor type, transformer type, resistor type, part winding type, or what else? Y delta, I mentioned it already, or across the line starter, then I do not consider it as a highly sensitive equipment. No? Usually this type of equipment or motors can handle the surges that may come in contact. No? They usually are. But if you are provided with a variable frequency drive controls as well as there are electronics in there, then my suggestion is for you to provide SPDs. Otherwise, you will be putting in danger your control circuits, which are usually more expensive than the one that I mentioned already, Y delta starters and so on and so forth. So to select, find a 40 ampere SPD, 600 volts minimum rating, and 40 kA nominal discharge current and 80 kA maximum discharge current. So let's go back to the slide. This one. Since your circuit is 440 volts, you will be selecting this 40 kA nominal discharge and this 80 kA maximum discharge current. Okay, so that's how you should specify your protection. Remember, this is only protection now inside your plant. Number 2 is inside your plant or manufacturing plant, while this one is inside your building or your house or office. So whatever is that sensitive equipment in your office, so maybe you can just follow this, make this way of specifying the surge protection. Okay? Let me go back to the chart box. If you have any question regarding this discussion. Okay, let's go back. Rexter Valdez Servil, is it allowable to ban the building system grounding with the lightning arrestor ground rod? No. The grounding of the electrical system of the building the ground rod for the electrical system of the building should be different from the ground rods of the lightning protection system. And so with the communication system, should also have a different ground rod. Take note of that. So usually in a building, there would be 3 different ground rods. Number 1, the one you use for lightning arresters. Number 2 is the one you use for your electrical system. And number 3 is the one they use for the communication. Okay? Number 4 question from Bunny. How many times of strikes limit of the SPD before replacing it with a new one? That I cannot answer, Bunny, because that would be more answered by manufacturers. But I believe the standard manufacturing is should be something like 10,000. 10,000. But of course, very difficult to count that 10,000 so many times that it operates, because the surge protective device will just function anytime it senses there is a traveling wave in the power lines. Then it will just suddenly, you will notice that there will be a blinking of the light. If it is you are inside your office and it functions, you will just notice a very fast blinking of the light. And that means that your surge protective device would have functioned. It would have allowed the passing of that big surge current to the ground. Okay, very fast. Okay, Mike Ramsey. Hi sir, good evening, good evening. How would you recommend using dissipation type lightning arresters? Well, dissipation type lightning arresters, is that the one that would throw away or would scatter the lightning surge to your neighbor? I don't know if that's what you mean. No. Because my suggestion is for the ESC type, meaning to say, it is bridging the surge coming from the clouds fast to the earth. Because there is the technology which says it will repel the lightning coming. When you say repelling it, then it seems like my thinking there is this technology is only good when you hate your neighbor. No? I mean, if you have a neighbor that is whom you always hate, or you're fighting him or her, then maybe this kind of repelling system is so I don't like it, because it's against the law of God. You have to love your neighbor. Huh? You should not kill your neighbor. Okay. Number 5. Is there a formula to consider for the calculation of sizing in the SPD? Well, based on my experience, I have not seen one that is being given, except that since most of these are done by practice, the range that was provided in the table for this low voltage system SPVs are based on the maximum that might have been observed as the surge protection, or the surge amperes, the lightning surge amperes. So, like in the 440 system, we are talking of maximum 80 kA, and in the nominal is 40 kA, and the maximum of 60 to 80 kA. And in the residential, it's about 15 and 30. 15 nominal and 30 maximum. So I haven't seen one. In school is nothing. It's only now that we're trying to put it in our standards. Marlito Marcelino Tagadan Baya. Good evening, Marlito. Sir, hina po yung voice. Oh, mahina raw ang voice. Let me check my microphone. Okay. Bring down my microphone. Okay. Okay. Money again. Thank you, sir. A follow-up regarding grounding rod, sir. Ground rod LPS. Ground rod SS system, etc. Are these rods to band, sir, or not po? Are you SS? You mean substation, Bunny? And ground rod lightning protection system and the substation. Okay. In the case of the substation, usually the grounding grid is only one in there. No? So we're talking of the lightning arrestor type, the varistor type. Usually there is only one there. What we are talking about as separate is in the building, when you have the active type protection, you must have 3 separate ground rods. Okay, because there in the building there is this communication that could be damaged, and there is also the electrical system where your surges from the lightning could also come to destroy some. Okay, so that's the reason why we have to separate it. But in the substation, of course, in the substation, if you have communication equipment like microwave and some others, their grounding should also be separate. Okay. To be banded. So Manny was clarifying. Are these rods to be banded, sir, or not? So I already have answered that. So we have to separate communication to the ordinary electrical distribution system to the lightning protection system. But in the substation, the grounding that we use is usually the same because we are talking of the lightning arresters. The lightning arresters, the varistor type. Okay. Mark, Giovanni is yes, I'm saying correct. So I answered it already, Bunny. And Mike Ramsey, hi sir, di ko po nadinig masyado yung sa question ko regarding dissipation type, lightning arrestor. Sorry. Oh, so, is dissipation, I don't understand the dissipation type, Mike. Is it the one that would drive away the lightning, or because the one that I'm talking about, the active one, is one that would absorb the lightning from the atmosphere and would just dunk it to earth, or just catch it and just ground connect it to the earth as fast as possible. So is dissipation type the one that would drive or repel the lightning surge from the atmosphere? If it is the one that would repel, then I wouldn't suggest it because it would be against my principle. Like for example, if you hate your neighbor, maybe this is the one that you're going to use to drive away the lightning. Instead of coming to your lightning protection system, it would be going or driving away the lightning to your neighbor's house or neighbor's building. So it is not good, in my opinion.